Hey everybody, before we start to do the word problems for this chapter, I'm going to go over some applications to kind of motivate you to regarding these equations. So this is from the respiratory program, so I'm just going to go over these kind of quickly and not in a lot of detail, but just so you can see what's happening. So we talked about gauge pressure. So gauge pressure, you can see here, you can use that to talk about the oxygen tanks and the pressure. You can look at it on the picture on the left there. That is going to be, you can see the tank is measured in PSIs, or pounds per square inches. Also, you can use gauge pressure to describe what's happening inside these rebreather masks. You have, if the pressure on the outside is bigger than the pressure on the inside, then the mask will be deflated. And vice versa, if there's too much pressure on the inside, then the mask is going to get inflated. So you can control that by knowing the gauge pressure. Next, you have these flow rate devices. For example, here, like you can see that this pipe here, there's these two small nozzles. So the smaller nozzles means that the air is going to flow faster through the smaller nozzles than through the sections that have the big areas. And if you notice there, the units are in liters per minute. You have another device where the nozzle size affects the flow rate. You can see you have, I don't know if I can show it to you here. Oh, I might be able to use this. Oh, excuse me. Yeah, I'm just going to talk through it. So the size of the nozzles there are going to affect the flow rate. Also here you can see that this nebulizer, you have different size nozzles, and the bigger the area, the slower the air is going to flow. The smaller the cross-sectional area of the nozzles, the faster the air is going to flow through. And if you look at here, you look at the bottom right there, L per M, I believe that means liter per minute of oxygen. So that's going to be a flow rate. Another example here, flow rate, so small nozzle sizes, air is going to flow fast. And more of the same here. Different nozzle sizes are going to make air flow at different rates. And then you have devices that mix multiple equations. For example, this rebreather mask. The size of the nozzle is going to affect flow rate, but the bag itself is going to control how much pressure, the pressure at which the person receives the air, or oxygen. Another example here, these recitation bags. Two things you have to take into account: the pressure on the outside versus the pressure inside the bag. That's going to be the gauge pressure. And then the rate at which the person receives the air, that's going to be the flow rate. And we talked about this one before. The smaller the nozzles, the faster the air is going to flow. And you can see here again, you have a different set of nozzles, and those will affect the flow rates.